Thank you, everybody, for being here. I'm really excited to share with you our journey to launching Lustre as a first-party service in Azure. So Azure has spent the last few years in building our cloud, purpose-built for HPC and AI applications. We have been offering virtual machines on the compute side, high-speed networking capabilities with InfiniBand, and also the express route capabilities, and trying to deliver the HPC capabilities with a true performance and price performance requirements as seen in the market and industry. Through this journey, we've been partnering with many of our customers and other HPC leaders, and we've been trying to develop solutions which meet the market as we are seeing. So the Azure HPC resource stack has been constantly evolving. On the compute side, we have the high-performing H series and the N series, and also the Cray capabilities as a native offering on Azure. We've always had the HPC cache solutions and the Azure NetApp files, cluster store, and most recently, we are launching the Azure Managed Lustre first-party product. In order to make this an overall solution, the workload orchestration systems with VM scale sets, plug in with Azure Batch or Cycle Cloud, have also helped implementing an end-to-end solution fairly easily by our users and customers. And more recently, we've had a tighter integration with Azure Kubernetes services to be able to bring in the cloud-native workloads as part of this ecosystem. We've built on top of these existing infrastructure services, additionally by delivering PaaS services like the Azure Machine Learning, Azure Data Lake, and ML Compute, so you can bring in your applications to be able to consume these services natively as well. With respect to compute, we have a wide range of compute capabilities, right from the lower end burstable virtual machines to the higher end or specialized VMs that I spoke about earlier, which is the H and the N series, which are high on the memory and compute capabilities, as well as the GPU rich virtual machines. So when you think of delivering Lustre as a managed service in the cloud, one would imagine this to be, bring in your own Lustre software, you instantiate virtual machines, attach disks to it, and tier it against blob. This would be, and also the users have to build their own client images from scratch, and also take responsibility to build the tooling around how do you monitor and operate Lustre. Pretty much everything other than the hardware which the cloud vendors offer on the Azure IaaS service, you're left to running, building, and operating a Lustre in the IaaS cloud by yourself. In order to simplify this experience further, we decided to launch the Azure Managed Lustre service. Its objective is to make it a simple click and deploy experience while we take care of managing and maintaining the service natively on our cloud. And in terms of a user experience, the users need to just identify a virtual network in their subscription where they're instantiating their client virtual machines. And we attach the network interface cards to virtual NICs against the virtual machines that are part of the Azure Managed Lustre Cloud. Additionally, we make it rather simpler for users to bring in a varied set of client VMs on the different operating systems available, and we provide you a pre-built Lustre client packages, which can be downloaded from packages of Microsoft.com. behind the screen, this is what happens in Azure Managed Lustre. We instantiate virtual machines which serve the three primary functions of MGS, MDS, and OSS, and they have attached disks, which is also a managed disk capability within Azure to natively store the data that Lustre OSTs and MDTs have to do. Additionally, we have capabilities for customers to bring in their own keys, enabling them to manage different authentication and access policies to the different data sets that they are storing. In terms of the hierarchical storage management, we have capabilities to tier against Azure Blob, and these are also hosted on behalf of the customer on the Azure subscription that we provide as part of the service. All of this is kind of deployed and managed by the resource provider. It instantiates the VMs and scales up and scales down based on the configurations that the customers create as they are building the Lustre cluster in Azure. We collect a rich set of stats and logs from this infrastructure, allowing us to manage and monitor a wide range of clusters which are deployed within our infrastructure for us to quickly pinpoint issues as they are happening in these clusters, and also react and respond back to customer issues as these clusters are running. So next, I'll go about our experiences deploying the 2.15 Lustre version. This is I think we are on 2.15.1, right, Alice? Yeah, so that's our latest version that we are delivering as part of our service. So, when you think about delivering Lustre on the cloud, a few of the capabilities that we have to, be constantly in tune with is to deliver the security patches, because you're running natively on Azure Cloud. The security standards of Azure Cloud for all our services that are delivered are quite stringent. So we address the CVEs within every 2 months, and we actively monitor for the vulnerabilities that are published, and make sure our OS versions and the software running on the server VM side of Lustre are updated. Additionally, we leverage the benefits of the security capabilities within Azure platform. With data at rest is always encrypted, and we get that for free because it's a managed experience provided on top of Azure. And whenever data is moving between the Lustre server nodes to the managed disks, we do leverage the encryption capabilities that are provided on the network, as well as the native storage encryption that comes up with the disks. We will be a globally available service. So in addition to the US security standards, we do meet the stringent standards of the GDPR compliance to provide security on privacy, on managing personal and sensitive data. And with respect to deploying the service itself on the cloud, we have a very narrow pipe of accesses, and we expose very few ports and cluster site services in order to prevent security threats. We are actively working on a more end-to-end encryption capabilities from the client side all the way up to the data that where it's stored, which is offered at no cost for the customers and at no performance penalties. Now let me turn it over to Alice to share a little bit around our learnings on the engineering side.
Thanks, and sorry for the 1-2 buckle your shoe here. We felt like it might be a little more appropriate on the really technical slides to have it coming from somebody in engineering, and since I could attend, why not? So what we're running on the server side, we're on Ubuntu 18. We're going to be moving to Ubuntu 20 fairly shortly. We recognize that's like somewhat non-standard, but it's been working quite well for us. We're on 2.15.1 plus a series of MS patches that I'll talk about in the next slide. These will be all upstreamed once we GA, which is near imminent. On the clients, we have to support a ton of these, which is basically at the bottom of that slide. But we take patches as needed from 2.15.2 and master, backport them in order to build, and are planning to move both of them, the packages on the clients that we provide as well as the server side, to 2.15.2 very shortly. The cloud's a really living environment, so we need to act on CVEs, and Dilip just talked about that on both the server and the client side. Obviously, we don't have control over the clients themselves because that's customer oriented, but the packages at least we release have to address these to the best extent possible. The following the listed RHELs, Almas, and Ubuntus are what we currently support. We're going to expand that list over time, but this was like the mission critical ones from the customers we spoke with. Our experiences so far on the engineering side is that stability remains really high. We started at 2.12, I think, like 3 years ago when we were developing this. We moved to 2.14 somewhat shortly thereafter. Really liked 2.14, but a lot of the features that came in 2.15 were attractive enough to make us take that leap back in November. We've seen 0 crashes, kernel hangs, or corruption so far. We stand up a lot of Lustre clusters in testing on a daily basis. I ran a quick query to see how many just over the last 7 days, and it came out to like somewhere around 750 Lustre clusters had been stood up. A lot of these are in testing. AWS, don't freak out yet. It's mostly dev side, but it's really exciting and kind of demonstrates our ability to all of our pipelines to stand up small or large clusters to run HSM tests or a variety of tests that are not unlike some of the things that are run in Garrett to exercise things. Performance is pretty comparable to 2.14. We did see a direct I/O bump when we went from 2.12 to 2.14 for small IOs, which I know was covered at last LUG or the LUG prior. But between 2.14 and 2.15 for the workloads we're focused on, it's remained pretty comparable and reasonably happy with it. 2.15's basically made support for newer kernels a lot more manageable as we show. We're like tracking a much newer version of Lustre as well as newer kernels than most people probably want or need to, which is just the nature of the beast at Microsoft's cloud. There's a lot of work getting these new distros stood up, but thereafter we have pipelines that basically check against whatever Ubuntu 22 has or Ubuntu 20 has, pushed in their repos for new kernels, rebuild against them, and re-upload those packages for customers to pull down. So I mentioned MS patches. We have the following to be upstreamed. I apologize, these were not upstreamed earlier. I've been in contact with Patrick and others about like, hey, we have this unfortunate pile that I've had to like keep, me and some others on the team have had to keep like up to date as we pull stuff down and there are conflicts. This is just a selection, but I thought they were most interesting ones we had. A lot of them focused around HSM improvements, so an action selective purge if you just want to get rid of the archives rather than the restores that were in your queue. PFL striping support for HSM imports so that you can import files and get something more than just like a really basic striping layout. Import performance when we stand up, and as the AWS guy showed, when you stand up a new cluster and you want to pull in all the metadata, that's a really performance heavy thing right at the start, and delays there prevent somebody from basically jumping on their cluster right away. So we've made some performance improvements to get somebody stood up quickly. Agent load balancing, the current policy engine for selecting agents was suboptimal, so we have some improvements on, especially for larger agent pools, selecting agents that are less busy, and making sure you don't get like 3 1-terabyte files assigned to you for a restore. And then a bunch of build and patch support against LDiskFS on newer kernels. Some bug fixes. There was a recent one that was breaking our kube usage that related to namespace support, and I think some of that came in as part of the IPv6 changes that have been flowing in, and there was just some places that ignored indexes. So with, especially in Kubernetes, when you have multiple devices that look the same by index but not by namespace, there was a bug there. HSM purge can send cancels to the incorrect agents. some LPROC stats displays. I think I already talked with somebody about this, one of the devs about this. So this may have already been fixed upstream, but is fixed as well in our code base. And a bunch of test bugs. The cloud has just a different environment, a different set of response times. There's a variety of things that make it unique. And so we've been slowly plowing through Lustre bugs to make sure that we run that basically on every commit. And so we want to make sure that we don't get like a bunch of false positives over things. I think it's back to you.
Oh, thank you. So more requirements from me to Ellis. One of the key things that we look at is how do we keep these clusters updated and running to the most recent compliances. So we ask for weekly maintenance windows where we have the capability to change configurations, apply any sort of hot fixes, and at some times, we perform full upgrades on the fleet of the clusters that we manage. Additionally, like when we need to take care of upgrading these Lustre clusters, then we have to go through not just the Lustre kernel file system drivers and the associated utilities and libraries and service, but all the the services and the applications that support running Lustre in Azure. So we do have to make sure they are updated with the latest bits of code on cluster node management and reporting. Our goal is to never lose any customer data. That's our key primary focus, and we want to be able to upgrade even large size clusters with minimal downtime in a target of 30 minutes we set ourselves at this point. We want to do obviously much better, and we have been in trials. And through the course of the upgrade, we want to make sure that the existing and the new configurations are consistently applied across all the cluster nodes. And at any point in time, if we screw up, the customers would have a way to roll back to a last known working state and be able to still continue to run their environment. So these are goals that we've defined for ourselves. And I'll let Ellis talk a little bit about how he does it.
Yeah, so we do upgrade in a very non-Lustre way because we're required to. We have 30 minutes. We can't ask the customers every single 30-minute window to unmount all clients to start. So there's a lot of fancy footwork that has to go on, and I'd like to file a formal complaint against Rich Moore for not showing his timeout presentation a year ago, because that would have saved me a ton of time. But key advantages here: we don't need to detach or attach the data disks, create new VM instances, fight with quota trying to get quota for a specific VM SKU. We keep that around. We just basically, I'll talk through the procedure, and just you guys can read the advantages, but because I think people are probably most interested in the procedure here. So we have a suspend and an unsuspend, and that basically bounds the upgrade. The suspend actions include adjusting timeouts such that clients aren't evicted during the upgrade, and enabling server-side firewalls so that at a specific point, so that we don't get all the nodes within the cluster can talk to one another, but clients from the outside are not talking with the cluster. We create new OS disks during that time. Those are the ones that are going to get swapped in to the VM if you're going from 18 to 20, or you're just bringing in fixes to CVEs like OpenSSH is broken or whatever. We do a put on those VMs to get the disk swapped, wait for the VMs, this is all VMs in the cluster side that is, to be brought up, validate the health of the entire cluster at that point, at least internally, because again, it's kind of gated from the clients on the outside, perform unsuspend actions, restoring normal timeouts, disabling the server-side firewalls, and then finally, as long as everything's gone well, delete the old OS disks on success, and restore the OS disks on failure. The old ones on failure. The key part here is that we don't want EIOs to end up at the clients, because that interrupts jobs, obviously, and ignoring the 30 minutes of everything stalled. Basically, clients shouldn't have to concern themselves with the fact that we're even doing an upgrade. I think that's it.
Thank you. So I was actually thrilled to share with you how we monitor, run, and manage multiple clusters. One of the key things that we learned from our trial experiences from our customers is this is a very valuable thing for Lustre savvy customers. And so we have been able to expose some of the cluster relevant metrics through our Azure Portal. Latencies by an individual Lustre node or a specific op type, the standard read-write throughput by Lustre nodes, and also ops per Lustre node or a specific operation type. Additionally, for more savvy users, we also let them view the capacity per OSS and MDS in the clusters that they're instantiating, allowing them to define quotas as they would need to for the multiple users on their environment, and so on. So here is just a quick snapshot. Oh, I only have a minute. All right, so I'll just sift through this, but we have these capabilities available on the read-write throughput side as well, and here are the other metrics that we display through the Azure Portal. Additionally, there are active stats that we track. Here is a shorter list as to what we actively collect on a per cluster basis. And these are helpful in defining our monitors and alerts, so we can actually determine a specific node's health status and be able to react on it. These are the health monitoring dashboards that our services and support teams and our engineering teams sometimes leverage in order to quickly drill down into which specific tenant cluster and node is experiencing issues. And we also have predefined set of Lustre cluster metrics that we can quickly sift through and be able to narrow down the problem. Additionally, this being a cloud-hosted distributed system, we have capabilities within Azure with an implementation of DGrep, and we have some predefined DGrep queries to quickly narrow down the problem and get to resolution. So that's the time that I had. Thank you.
I'll go first this time. I have a question. First of all, I see the cloud vendors coming into the Lustre arena is quite welcome, quite important, your inclusion and infusion. The tests matrix that you have, at one point you said you are testing hundreds of different configurations. Do you provide a list of your test matrix? What configurations are you testing? Is that open to the public or?
It's not today, but there is, in the interest of advancing the community, we don't see why not.
That will be very welcome. The Lustre, traditional Lustre developers have their own test matrices, but that's limited resources, limited applicability problem, and the user facilities are testing only the things that are relevant to them. So there are a lot of gaps. Your input over there will be quite helpful to the community.
Yeah, obviously, I mean, we are, being Azure, the customer data is kind of like, in our engineering tests and benchmarking, obviously, I mean, I think we are very happy.
I'm not asking about customer, what you are testing.
Customer-led tests are going to be much more.
Not that, but the configurations of what you are testing, what parameters, OS.
Absolutely,
Okay.
yeah. At the engineering level, yes.
Yeah, that's all, yeah.
I was struck with your upgrade procedure that you basically have a sort of stop the world and rely on timeouts approach. So Lustre has failover, which is often used to do rolling upgrades. So I guess there's my question. Talk about why aren't you doing that? Just curious.
That's an Ellis question. Okay.
Yeah, we only get 30 minutes. So when you basically stand up a cluster, you select a 30-minute window that's amenable to you. that's every week. We don't do upgrades every week. We're expecting it'll be like 3 to 6 times a year based on CVE history and whatever. But we don't tell a customer like, hey, this week we don't do that dance with, because we're expecting hundreds or thousands of customers. It would just be a pain, and they're all at different times. So we get that 30 minutes. If we try to do a rolling upgrade in that time, we would just never make it with larger clusters. So we needed something that is like a pause the world and move on. I agree, rolling upgrades like super sexy, but we just don't have time for it, unfortunately, with the window we get.
I guess sort of the point of the rolling upgrade should be that you don't need a window, right?
That's fair. The other aspect was a lot of the need for HA is because you don't have a lot of the offerings within the cloud, like managed disk and other things that like protect you against that. So I think this is like really interesting. We should take it offline. I'm not the upgrade engineer, unfortunately. I'm more on the HSM side, so I reflected most of the steps that he's taken. But yeah, the answers I got were all around the 30 minutes window that we get. So.
And we don't need the entire 30 minutes to. I think it's just for us to be twice as fast. We are twice as fast, at least in the clusters that we've seen. But if there are issues and errors, we take the time.
Would we be able to talk to this upgrade engineer that knows about the battery files? Would you be able to talk to this upgrade engineer?
Yeah. Why don't we connect and we can probably discuss this offline? Thank you.
So one question I had was, because you're monitoring, capacity and usage and stuff like that, do you have any kind of, offering to say, you're hitting 80% full, add another 25% OSTs on the end or MDTs automatically as a service offering?
Yeah, I mean, those are features that we are actively working towards, and being on the cloud side, the simulations are fairly well bounded. So what the experiences that our customers have had is spin down and be able to spin up a larger environment, and it's been rather easier for them to do that. But this is something that would make it simpler, so we would consider that.
Okay, please thank Dilip and Ellis of Microsoft, and we'll continue with our program.